So thank you so much. I will share my screen now. Okay. I believe you can see my screen. Can you please?
Yes, ma'am.
All right, thank you so much. Sure. So can somebody please help me with what we did yesterday? What do you grab anything and do you practice? If there's any question before I go through it again. Any question from what we did yesterday? Hypothesis testing, t-test, one sample t-test, two sample t-test, chi-square test. Any question on that? Any question on that, please? Okay. I will take it as no question, but I will go through it again. Okay. Okay. Notification. Stop for turn off all notification. Does. Okay. So yesterday we look at hypothesis testing. So we were able to touch on what hypothesis mean, and we talk about two types of hypothesis, the null and alternative hypothesis. Then we look at the decision rule, and the decision rule is that if the p-value is less than or equal to 0.05, which is 5%, we reject the null hypothesis. Then if the p-value is greater than 0.05, we would say we fail to reject null hypothesis. Why are we saying we fail to reject null hypothesis? It is because there is no enough evidence of any difference, or if it's significant. That's why we are saying we fail to reject null hypothesis. Instead of saying that we accept null hypothesis, we just say we fail to reject null hypothesis. So for the sake of those that are not here, please let me explain what hypothesis mean. We mentioned that hypothesis is a claim about your data. You can just say anything, like make a claim saying, oh, there's no difference, like this program did not benefit people, like there's no difference between those that benefit and the one that did not benefit from a program. That means you are saying that you are making a claim about the information you have. You are just suggesting, you are assuming. That is what hypothesis is. And we have null hypothesis. The null hypothesis is the one that is always stated in form of no difference. So you can say that the age is 30. So you are saying that any other thing than 30, or you say is 50, you are making claim that no, the average age is 30 or is 50. So whether it's 51 or it's 52, is 49, you are saying no, it must be 50. So that is a kind of null hypothesis. So it is not every time that it will be straightforward that you say there's no difference. What it means when somebody is saying that no, the average age or the average income is this particular value, so you are saying that any other value, like it's not possible to have any other value. That is why it's always stated in form of no. It is no significant difference. There's no difference at all. Then for alternative, it's always straight. And that is the one that is proving the null hypothesis wrong. Okay. So we talk about t-test. T-test is a type of inferential statistics that we use to check the difference between mean of one variable, or when you are considering a variable that is continuous and You also have categorical variable. What you are doing basically when you are talking about t-test is you are trying to look at the average. You are looking at the difference between average of a variable, or you are comparing, is either you are comparing it to a given value, or you are looking at it between two groups. So when you are dealing with t-test, you are dealing with, is either you are dealing with one continuous variable against a given value, and that is example of one sample t-test. In a situation where you are comparing the average of one variable between two groups, then you are talking about two sample t-test. And here is example of one sample t-test. If we are saying that we have this data set, the one we have cleaned, the combined data, we want to look at the average age of our household head. So we are giving example that we want to look at this question: is the average age equals to 30? Automatically you are already saying that the hypothesis saying that the average age of household head is not greater than or is not equal to 30. So you are saying that the average age of this respondent is 30 in this situation. Now how do you do that? If you want to perform this analysis in starter, you can use point and click, and you can use command to get this done. So let me go and bring in my data, then we'll practice this. Is either we use this part, we click on statistics, you will see summary, table and test. You click on it, then you scroll down to see classical test of hypothesis. When you click on this, you will see one sample t-test, you see two sample, you will see other ones. So this time around, because there's a given value, we want to check if the average age is equal to 30. So we are going to use one sample t-test. We want to look at the mean of the average age of our household head respondents. If it's equal to 30, is it statistically different from 30 or not? So that 30 is our hypothesized mean. And after you have you select the variable you want to check, which is age. In another scenario, it can be income, it can be height, it can be length, it can be any continuous value. And the hypothesized mean will be the given value when you are dealing with one sample t-test, and you click OK. So let's do it together. Okay, so I want to go and bring in that data now. Combine cleaned, I will say OK. So this is the data that I'm using. Let's not forget, this is what I have at the back end. So I can use command. If I say t-test, I already know that it's t-test that I want to do. T-test age equal 30. I want to confirm, and the result will come like this. I'll come back to how to interpret this result. I want you to know how to do it first. So this is me using command. If I don't want to use command, you do not remember the command that you want to use, you can do point and click. Now let's not forget that I told us that you can always seek help. Let's say you know that you want to do t-test, but you are not sure of where to go, like the point and click, you are not sure. Instead of you stressing yourself, you can seek help, and you say t-test. It will give you the direction. So this is already telling you that if you want to do one sample t-test, you can do t-test, put the variable name and say equal, put that value here. All these ones are optional, like when you want to give option, maybe like, but let's stay here as beginner. You put the value that you want to test. I'm coming to two sample t-test. Now you want to use point and click, just scroll down, scroll down and come here. This menu is already telling you that t-test, go to statistics, summary, table and test. After that, you go to classical test of hypothesis, then type this, you choose t-test, that's mean comparison test. Don't stress yourself, so you will not be going back and forth. You can copy it, bring it to your command window, you paste. It's not as if you are going to run it, it's just for you to be seeing it so that you know the next step to take. So I'm supposed to go to statistics, so let's go there. Statistics. Then it's saying you should look for summary, stable and chest. This is it. The moment you click on it, it's saying that you should pick classical test of hypothesis. You come here and pick classical test of hypothesis. The last thing is t-test, the mean comparison test. That does not mean that you cannot also run any of these analysis, but it depends. Let's just focus on this. So if anybody asks you, can you analyze this data, and you can see that you just want to compare the mean of a continuous value with a given value, you do one sample t-test. Now you come here, what I want to do here is t-test, and it's one sample. I will just pick one sample. Which variable am I testing? I'm testing age. What is the hypothesized value given? We want to check if it's different from 30, and you say okay. Do you see? Just like I mentioned that even when you use point and click, starter will help you to write the command. So this is the command, and you can see that it is not different from the first one that I wrote. Okay, so this is the result. Now it is time for us to interpret these results, our one sample t-test. Now the hypothesized value, you can see that starter will even write everything out. One sample t-test is the inferential statistic test we are conducting. It is written here. This is the variable we are looking at, age. The number of observation is 3,885. The mean age is 53.90, which is the same thing, because this is the same data we have been using. Even for descriptive, you know that this is the mean age, and this is standard deviation, 95% confidence interval. The mean age is what we are looking at. Now this is null hypothesis. It's always written like this. So when you see h naught, that's h, then there will be underscore 0. It means null hypothesis. An alternative is always written as, is either you see h underscore 1 or you see h underscore a, like this. Now the null hypothesis here is saying that mean equal 30. This is what we are testing against, and the alternative here, this middle one, is what we are considering now, is saying that mean is not equal 30, and the p-value is 0.000. And what is the decision rule again? The decision rule is that if the p-value is less than or equal to 0.05, you will reject the null hypothesis that is saying that the mean age is not different from 30. So we reject it. It is not correct. So from this result is showing us that it is statistically different from 30. So what is going to be our decision? We reject the null hypothesis, meaning that the average age of our household head respondent is not 30. So that means it can be greater than or less than 30. But look at this result now, just in case if somebody is saying, oh, it's less than 30. Here you see that if you say it is less than 30, this is not significant because it is actually greater than 30. That is why this is significant. Look at the mean age for you to know that it really makes sense. Just that scientists, journals, they like to prove something and say, tell us, is it scientifically significant or not? Mere looking at 53.90, you should know that it is not equal 30. But is it significant? Yes, because sometimes you can have 31, 32, and on average it may not be statistically different from this 30. But obviously the result is showing us that it is not equal 30. So this is example of one sample t-test, and this is how to run it. So please, for anyone listening to this recording, if you have any question, you can reach out if you are not present here. Now let's move
No, ma.
to,
Sorry, ma.
yes ma.
Sorry, can you go back to the result table?
Okay,
Sorry, ma'am.
Thank you.
Yeah. So the second alternative hypothesis in reporting, is it just a guide or you need to report it as well?
You can report it.
Okay,
You can report
because
it.
it's significant
So
and
this
it's
result now, if somebody, because we are not just saying that it is significant at 5%, we are using 5%. We are considering 5%, but this result is also is significant at 1%. We are only saying that it's acceptable if at least if it can be less than or equal to 0.05, and we accept my result. That's the 95% confidence interval that we set. So but here this result is, so it is not even by chance at all. It is significant at 1% itself. I hope this part is clear.
yes, ma'am.
That I pick 1%, because if you look at this is 0.0, in fact this is significant even at 1%. Three significant level that we consider 1%, 5% and 10%. 1% is better than 5% and 5% is better than 10%. So this result is not even by chance at all, because it's significant at 1%. Okay, thank you so much, ma'am. So you can report, the significance level and say it is significantly greater than 30. Okay, now the interpretation of results is what we have done. If the p-value is less than 0.05, that means the average age is significantly different from 30. Now if the p-value is greater than 0.05, we will say that there is no significant difference. But thank God it's different. We can all see it, like there's difference. It is not the same thing as 30. 50 and 30 are not the same thing. Okay, so that is what that means. So we move to two sample t-test. Two sample t-test is also referred to as independent t-test. Independent t-test. This is coming from the assumption that the two variables that you want to consider, they are independent of each other. That means they are not our observations are not related. Not that because my friend is saying A, me too I'm saying A, our other friend is saying A, we are saying A. No. So you see, this one it will come from the way you sample. No bias. Okay. So when do you suppose to use two sample t-test? You will use two sample t-test when you have a continuous variable and you have another categorical variable. In t-test we are only dealing with, in two sample t-test we are dealing with two variables. So the first one is going to be continuous while the second one is categorical variable. So you use it to compare the means between two groups. An example of this is if you want to look at this question now, is the average age of men different from women? So you want to test the average age of men, is it different from women? So you can also use this point and click, or you write the command. So for the for the point and click, if you look at the help that we seek, I'm doing this because by the time we finish this class, maybe like from March, you may want to try some things on your own and you say, and I will have asked this question, I didn't know I would see this. Don't stress yourself. Now that you have the software and you have basic knowledge of what all these things entails, you can seek help. You can even browse it. Like what you want to do, you will get idea of how to do it. But trust me, I will be available to answer you. Now for the two sample t-test, you can come here and say t-test, put the variable, this variable name, then you put comma because this time around you want to do optional. Then this one we want to check the average age of men and women. So it's going to be t-test age, you put comma, then I will now say by, maybe I want to look at it by gender because I say men and women, so I put my variable name is gender, so I will put here and I will say enter. No issue. Let's come here, point and click. Okay, this same part you will go through the same part, but this time around you will now click on two sample t-tests. So I want somebody to guide me. Let me keep quiet and somebody should just guide me. What do you think I should click? Anybody? Mr. Lawan don't talk in class. Are you there, sir? Abi, are you driving?
Hello, good morning. No, I'm not driving.
Okay. Oya, try to guide me.
Okay, you click on statistics.
Okay.
Now I'm lost.
Are you with your laptop, sir?
No, not now.
Okay. Another person to help Mr. Lawan. Let's do it together as group. Where should I go to?
You should go to classical test of hypothesis.
Okay. I'm there.
Yes, and you click on t-test, mean comparison test.
Okay, thank you. So what else? We want to check
Two
if the
sample
average
using
age.
groups.
Sama?
Two sample using groups.
Okay, I've clicked to sample using groups. So which one is going to be the variable name?
Age.
Thank you. It's going to be age. And what will I put under group?
Gender.
I'll put gender. Thank you so much. And I will leave this at 95% and say okay. Okay. So this is the result of two sample t-tests. So now we want to interpret, but before we interpret, let me put us through this so that we understand what we are doing. Because somebody can just bring, especially if it's job interview, they can just give you this result and say, can you explain what this result is saying? You may quickly want to jump to say, oh, it is significant or it is not significant. But if you pay attention and you read this, I always advise people, like say, even if they give you something that you have never seen before, take your time to go through it, then you will see that you can apply knowledge of what you know on the new thing that they are giving you. We have two groups. We have male and female. And this is number of observation. They can bring question like how many people, how many respondents are male. You know, this one, it is no longer descriptive again, but the result of descriptive is here. So that means I have 3,216 male, while 669 are female. Now this we are looking at age, right? The mean age for male is 52.45, while the mean age for female is 60.88. And all these are standard deviations, are like how they differ from each other. Now this is also showing us combined for both male and female. This is the total, and this is the average age of the two of them on average. This is 53. It is still correct. So that means you can even get your one sample t-test here to at least give you the mean age. But this time around, the difference between this male and female on average the age, the mean age of these two, the difference between them is minus 8.42. Minus 8.42. So you can see that they are different. It is giving you minus because it's considering male first. So but we are going to take absolute value here. Now the null hypothesis, that if you like state it in paper, if you like don't state it, when you are doing your analysis it will be there. This is the null hypothesis. The null hypothesis is saying that between the average age of male and female, the difference between average age of male and female is equal to 0. In another way, you can say that there's no difference between average age of men and women. That's why you are saying is equal to 0. You know, software we always write in numbers. So this is saying that there is no difference between average age of male and female. This is 0. The research question is that, is there difference between the average age of men and women? This is stated in mathematical form. Now this is the alternative hypothesis here. The alternative hypothesis, this one that is saying that it can be less than 0, it is significant, because this one is saying, this part now is saying that male are, on average, male have higher average age compared to male. This is it. If you look at it like this, it is less than, the difference between them is less than. But always focus on this middle one, because this one is not looking at either the downside or the upper side. It's just stating that there's no difference, and the alternative is saying that there's difference. Okay, so this is it. So there's difference, because this alternative is saying that the difference between the average age of men and women is not equal 0. Is not equal 0. This is null alternative hypothesis, and it's significant. So can somebody tell me the level of significance that I have here? Anybody?
0.01.
0.01. So it is because it's less than 0.002. So this is significant at 1%. 1%. You know, 1%, it can be less than or equal to 0.01. So this is significant at 1%, and it's because we are using 5%. We are saying that if it's significant at 5%, and we accept it. So it is even significant at 1%, which is better. So any question? Any question? Or should I move forward? Okay, Mr. Ben, please ask your question.
Yeah, I've been trying to understand when you say it's significant at 1%, 5%, and 10%.
Okay.
And I'm trying to look at the results,
Mm.
Rolling my eyes around it, but I can't find any place where I see 1, 5, and 10%.
Okay. Thank you so much. You see, when we talk about 5%, if you have calculator, with you, if you put 1%, 1% is 0.01. So the p-value at 1% is 0.01. So the decision rule is always that if it's less than or equal to 0.01, it can be less than. So any value that range from 0 to anything that is less than 0.01, it can even be negative. So from anything less than 0.01, any value in front of it up to that moment of you have 0.01, that is 1%. Significant level 1%. Are you there, sir?
I'm listening, ma.
Okay. Then we have another significant level, which is the common one that people settle for, is 5%. 5%. If you punch calculator and you press 5%, that is 0.05. So this number can be less than or equal to 0.05. Then you will say, oh, your result is significant at 5%. Is it clear, sir?
Okay. Okay. Yeah, I understand now, ma. Thank you.
Okay. Then for 10%, it's going to be 0.1. Okay. So that three significant level is what we use. Sometimes I say, why can't we just say 80%? Why can't we? But I understand that when you are choosing, that's the three significant level acceptable, because the you are saying that you are 99% sure of your result, that this result, that the result happened by chance is just 1%. You are giving that chance to 1%, that maybe something is just by luck. Let's use luck, but we don't use luck in in research. You say by luck is just that 1%. So that's why you will say 99% confidence level, and the p-value there is going to be 1%, which is 0.01. So if it's less than or equals to 0.01, that is 1% significant level. Then when you say you are 95% sure, mommy, no, you are 95% sure, like confidence level, you are giving the 5% to chance and say, you see that 5%, maybe to chance, I'm giving it to chance, that maybe it just happened, this result is correct 95%, but I'm giving chance, so like the likelihood of something happen, I say maybe 5%. I don't want to mention error. Say that like it happened by chance, maybe 5%, but you are 95% sure. So this is what the p-value will tell us. If we look at this p-value, we normally say t calculated and t tabulated, but I don't want to go that route, so we not complicate the issue. Focus on when you have your p-value. We also have the t-value, like this, but it's the same thing. I don't want us to cram it. For the t-value, if it's 95%, it's always 1.96 on the four-figure, is it t table that we'll call it. It look like four-figure table like this. Okay, so this is what we are interpreting, sir. Is it clear, sir?
Thank you, ma. It's clear.
So to be sure that it's clear, can you interpret this one for me? If the null hypothesis is that the difference is less than 0, or let's even leave it like this, that is equal to 0, the null hypothesis is saying that it is equal to 0, and maybe at the end of the day, if I now run my result, I have this, that the difference is greater than 0, and I have this p-value, is it significant or not? Let's use it to be sure.
I would say significant, ma.
Is it significant? Okay, this is not significant. Is this okay? At what level? That one will help us to know, because I need you to understand it before we leave here. Please, at what level? If you write it down, look at your p-value. Anything less than or equal to 0.01, it is significant at 1%. Mr. Ben, please help me write. Then the p-value that is less than or equals to 0.05 is significant at 5%. Then when the p-value is less than or equal to 0.1 is significant at 10%. So this is my p-value is 1.0. Is it significant or not?
Okay, ma. Since significance will be at 0.1 or 0.05, that means it is not significant.
Thank you. So it is not significant. I didn't be is even if the p-value, let's say, is equal to 0.1, you will say it is significant at 10%. So I'm saying this because you can come across something like that. If the variable is very important to people, they will say it is not significant but at least it is significant at 10%. So that means like 10% that the result is okay, you are leaving it. The likelihood that the results occur by chance is just like 10%. It's just by chance, by luck. So if you now look at this is zero, this is the highest you can go, 10%, 0.01. If you have 1, the p, if the p is equal to or it is within the range of, let's even say 0.8, it is not 0.8 or even 0.2, it is not significant because this is more than this. It's supposed to be less than. So looking at this, if the p value is 0.2, it is not significant. If it's 0.12, 0.11, it is no longer significant even at 10%. Not to now talk of when the p value is 1. Is it correct, sir? Do you understand, sir? Mr. Ben?
Yeah, thank you, ma. I'm good. I understand, ma.
Thank you so much. Thank you. So, and that is it. We select age, then we put the gender, then the group is defined already. It's not compulsory that it will not be equals to male equal 1, then 2 is female. It depends on how you define your own. It can be 1 and 0. You still get your result. And you interpret. If the p value is less than 0.05, you will say men and women differs in average age. You can state it in your own English. But if it is greater than this value, no significant difference. So there's significant difference now. So we move to chi-square test of independence. Chi-square test of independence. So when are we what does chi-square test? What does it test? Like what are we using it for? We use it to check association between two continuous variables. This test, chi-square test, check for association between two categorical variables. And like, is there any association between these two? Okay. For scientists, they will tell you like association is not the same thing with relationship. It is not even the same thing with causation. Sometimes you can even use it interchangeably, but they will tell you no, it's not the same thing. So please, chi-square test, check for association between two categorical variables, not between two continuous variables, not between one continuous variable and one categorical variable. If you have something like that, please the right test to use it, two sample t-test. But if you now want to check association between two categorical variables, you use chi-square test of independence. Example is this. We may want to check, is marital status related to sex? Marital status, is it related to sex? We want to know. Okay, so you go to, because this is two categorical variable, the best test is chi-square. It is not even regression. So we go to chi-square test, and the part is you click on statistics, summaries. This time around you are still picking summaries, tables and tests, but this time you pick tables. I put these tables here because it depends on the version you are using. Let's not be that tomorrow you now have 19 and you say there's no frequency table in my own. What do I do? That's why that help is there. So you go to tables here, then you say two-way tables with measure of association. Let's test something before we go. Please, if anybody is connected, of course we are all connected to internet. If you can browse online, type online that you want command for chi-square test. Somebody should please, if I have like 3 people doing it simultaneous, I will be glad, so that if you have different command, we'll be able to iron it out now. Please type it online. Let me see, is my second system, is it connected? We did it yesterday, but I want us to be able to like stand on our own when you want to do any analysis now. So you are looking for command. Please type command for chi-square test in starter. If you are there, please let me know. We did it yesterday, but I
Yeah,
want you
done.
to we can use point and click. If you are there, please just speak. I can't see your us here.
Okay, you
Mr.
said command and you're
Adesina,
talking
Mr.
about point
Lawan,
and click.
Mr. Omoshola.
Yes, yes. Which variables are we using specific?
Okay, we want to check association between marital status and gender. Association between marital
Two.
status and gender.
Okay, there are two ways here. It's either
Two.
you type tabulate. There are two ways. It's either you
Okay.
write tabulate,
Uh-huh.
then marital status,
Okay, thank you.
then gender.
I should just put gender.
Yeah. Then
Is
after
that
gender,
all?
you put comma. No, you put comma after gender.
Okay. Comma.
Then chi-square. Chi-square, that is CHI2.
That is correct. Please, even when I'm not there, that's what I asked Dr. Abiodun
Then
yesterday when
so
she said,
the other, sorry, can I finish? The other one, there is an easier way. If you don't have to type tabulate in full,
okay, yes,
put
tab.
tab.
Uh-huh.
Yes. Then marital status, and
Mm-hmm.
then gender comma, then square. It will still work the same.
So, I mentioned that in starter, you can either type it in full, your command can be in full, or you shorten it. Like tabulate can be tab, summarize can be sum, it will still work. Okay, so this is it. I don't want us to don't be scared of analysis. There's nothing there. If you have foundation, just like somebody that already know how to calculate number, you already know 2 times 2, this one, they will start like that. Before you know it, they will move it up and say, oh yeah, go to multiplication table 3, go to 4, go to 5. That is the same thing in analysis. People are transitioning from data analysis to other tech area because they already have foundation, and when you have foundation, you can build on it and divert your attention to anywhere you want to be. So please, it's not difficult. This is simple basic knowledge. Then you try to build on it by taking challenge, take work. When people give you job, take it, try to work on it. If you need help, you can seek for help, but don't say, oh, I don't know it. We didn't do that one in class on purpose. Since last year that I've been doing beginners class, people have been asking, when will you do advanced? I say, hold on, go and be that one that you have, go and be building on it first. Okay, so this is it. Because we already know what we want to do. Oh, is chi-square that I want to check. I have 2 categorical variables. They are talking about marital status, which I know that it will be in level. Is either you are married, you are single, or I have 4 groups: married, married monogamous, married polygamous, loose union, divorce, separate, widow, never married. Then I want to compare between gender, male and female. The right test is to use chi-square test, and this is how to do it. So this is the command. This is how to do it. Tabulate marital status, gender, then you put comma, which is optional, then you put option, then you put the test you want to do. We can also do point and click. You come to statistics, then you click this summary table and code. This time around, please come straight to frequency table and you come to two-way with measure of association. Now, which one is row? Which one do you want? This is row 1, row 2, row 3. Which one do you want to have here? I want to have marital status, and for column I want to have gender. Which test do you want to do? Pearson chi-square. This is the most common chi-square test. Then you will say okay. Is it different from what you copy online? No, this is the command. Now, can we interpret this result? This is the result. So we are testing if there is association. The p-value is what will tell us if there is association or not. This p-value. So is there association between marital status and gender? Association between gender and marital status. Is there association? Looking at the p-value. Somebody should interpret the result for us. Please help us. We are not sure. Anybody? Let me see who is in the room.
Based on the results, ma.
Yes, sir.
I think there is association between marital status and gender. Because the level of significance is 0.000. But I don't know. I think we are working by 0.05, right?
Yes, it can be less than or equal to.
Yes, so it is significant.
Okay, so it is even significant at 1%. But if you just stay within and say I'm working with 5%, you can say it is significant at 5% and 1%. So it is significant. So that means there is association between marital status and gender. So thank you so much. Is there any question? Any question, please?
Well, I don't know. I have questions, but I don't maybe to the end of the class, because the question I want to ask is, apart from the table that we have been able to produce, the write-up, how is it going to be? Is it going to after the table, are we just going to state that okay, there is association between the two variables, or we are going to be putting the values against one another?
Okay.
I don't know. I just want to the write-up that follows. Yes, ma.
Okay. Researchers in the house. So I understand. Okay. So this is it. This is how to interpret. Now, for chi-square, any result you want to do, you see, I put interpretation. You will say anything your result is saying. You can say according to table this or table A provide information about provide chi-square test results of association between male and female average age, for example. Now you will interpret your result. You are not going to be repeating number. They can see the number inside the table already. If you want to talk about number, you will just pick the number that is significant, because sometimes when you are interpreting results, you can have the ones that are not, especially in regression, the ones that are not significant. Don't waste time. They don't need it. This is not significant now, except if that's maybe that's your main variable that you are testing. If somebody is doing gender analysis now, and in your analysis you notice that gender is not having any impact, you can interpret and say gender does not significantly affect so. But this is how to interpret this result now. This chi-square. Now, when the p-value, you already look at it and it's significant even at 1%, that means there is significant association or relationship between sex and marital status, but they prefer to use association. We use it interchangeably, but When you are doing chi-square test, they will tell you So there is significant association between sex and marital status. Sex and marital status. So that's basically interpretation. But when you are now discussing your result, because I noticed that you are looking at thesis presentation, now you will now begin to discuss and say this, what does that mean? If there is association between sex and gender, you will add flesh to it. What does that mean? What is other journals, like other papers before your own, what are they saying? You can now say, oh, it is in consistent with results of Omoshola 2024. Do you get? Then if it's policy variable, you can talk about the implication, like, okay, we should try to do this, check the distance, male are significantly going to be kini kan, maybe single, or and this will need more tests. But what chi-square test just do is to check, is there association or not, case closed. It will not test more than that. That is why we have other tests that are far, that will still shed more light than just looking at is there association between them. Now for ANOVA, because that's the reason I asked Mama to help me group this marital status, because if I look at this marital status now, I have more than 2 groups. And for chi-square test, you will use it when you want to compare 2 categorical variables. Let's do this. I want to generate marital stats, like I asked Madam Oluwatoyin to do yesterday. Generate marital status equal 0 if Mama, please look at this, because yesterday we took like 3 steps, but I can easily use this link. I'll say generate marital status equals 0 if this my marital status, because I can see here anything that is greater than 2 should be single. If this marital status is greater than 2, so these are single people, singular people. So I will now say replace this math equal 1 if math equal missing. Okay, so it is perfectly done. This is example. Let me tabulate so it will be clear to us what I've done. You know, we have done this as part of our data management. This is me transforming my data. I just want to regroup. I think it's Mr. Gomez that asked how to generate. So this is what I've done here. I generated another variable. I call it marital stat because I already have marital status. They are saying the same thing, but this one I want to put it in 2 groups. So I put single. I will know in my mind. Or can somebody help me to recode this? I want to assign value to it. Just that marital status is already defined here. So 0 is single. I will note it somewhere. Single is 0. Then married is 1. So these people that say married is either polygamous or monogamous. This one, these 2 together, they are married. You see all these loose, divorce, separate, widow, never married, they are single. This is what I've done. Somebody can please press calculator to show us, please. This is 84. Somebody please help me. 2,285 plus 678. Are we doing it? because I like to confirm. Is there missing value here? Let me look at it. If it's greater than 2, it should be 0. I want to go and check. If there's error, I will quickly see it. This is marital status. I know it's far. Okay. From here, it's supposed to be. Okay, which is correct. So this is it. These people now, all this married upward, I gave them 1, otherwise 0. So all these other people, they are single. So I don't think there's error here. So this is it. I just put it in 2 categories. Do you have any questions before I move to the next one? I want to talk about ANOVA. Can I move forward?
Yes,
The
ma'am.
network dropped me.
Yes, ma'am.
Okay, thank you. So please, let's not forget, you are using chi-square test when you want to test association between 2 categorical variables. Now there's something we call ANOVA. ANOVA will check for the mean across 2 groups, across more than 2 groups. Let me bring us back to 2-way. This is 2 sample t-test. 2 sample t-test. This will compare mean between 2 groups. For example, male and female. It's just 2 groups, right? You can also have education and you have learned, not learned. That is still 2 groups, right? What about a situation where you have maybe like education level, you now have primary, secondary, tertiary? Can you see that it is now more than 2 groups, right? My people respond.
Yes, ma.
So in this situation, please, you have moved past these 2 t-tests, and the next thing is ANOVA. You see, anytime I talk about this ANOVA on my page, people like it because a lot of people use this ANOVA. I don't know whether you are in maybe this pure science, pure and applied science, they check it. Like, is there difference between these groups? They use a lot of people use it. Not so doctor, when they are doing the analysis. Social science, almost everybody use ANOVA. So ANOVA is used to compare means across more than 2 groups. Why 2 sample t-tests will only compare means across 2 groups. Can we see it now? So this can be more than 2 groups. It can be 3, it can be this. Okay? So example of this is, we can say, is average age different across marital groups? Is average age different across marital groups? That means when I say mean, you already know that you are dealing with continuous value, numbers. It can be decimal point, it can be anything. The average across more than 2 groups, then you use ANOVA. For the purpose of this class, we are going to stop at 1-way ANOVA. 1-way ANOVA. By the time we say 2-way ANOVA, okay, let's do this one, then I will introduce that one to us too. So for 1-way ANOVA across marital groups, please, on purpose, I generated this one, this marital status. I want somebody to tell me if I want to do 1-way ANOVA, am I checking this marital? I want to look at the mean between marital status and age. So is it this marital status I will use for ANOVA, or this marital status, the one with 7 groups and the one with 2 groups? Which one is perfect for
The one with
ANOVA.
7 groups.
The one for 7 groups. It can be 3, it can be 4, as far as it's more than 2. But if it's just 2, please go and use 2 sample T tests. So thank you so much. God bless us. So can somebody help me now? What is the command? Like you're on your own. You don't know, like, and I want to do ANOVA. Oh, I already know. I have age and I have marital status. So what are the ways if Dr. Yemi is not here and you want to do it, or your supervisor is not around, or is like you have access to internet, or let's say you don't even have access to internet, what you have your software, how do we go about it? Somebody should just, all these things that we have been saying from the beginning of the class, let's try to apply it here. You're on your own. I did not give you command. You don't know, you want to do ANOVA. You understand that it's ANOVA that you want to do now. So what will you do? SAS and mass.
Just type F ANOVA.
God bless you. Type F ANOVA. I already know that it's ANOVA I want to do. Do you see? No issue. ANOVA means analysis of variance. Somebody say I should not say it means. ANOVA ANOVA represents analysis of variance. I say okay, thank you. So this is the syntax, this is the command. ANOVA, then you put the variable, you put that comma, and you put the other option. No issue. Please come to this place, copy the menu, so you do point and click, and starter will write the command for you. Okay, I'll come here, I'm pasting it. The first place you say you should go to statistics. If the version you are using is different, to give you the right one. Then you say I should go to linear model and related. I am there. You now say I should pick ANOVA or MANOVA. I pick ANOVA. MANOVA is talking about multiple, but I'm not going there today. ANOVA, I've picked. You now say I should pick analysis of variance and covariance. Now, which one is dependent? What's our question? Let me see. Where is it? Is average age okay?
Marital status.
Marital status. Where is it? Okay. Did I pick it twice?
Sorry, is age a dependent variable?
I think I picked it twice. I'm coming.
Okay.
Okay, let me do it again, please. Statistics, linear, ANOVA, analysis of variance and covariance. Sorry, it's one way that I want to do. I pick one way because that one, it can be anyone. Like I put marital status twice. The response variable is age, and the factor is marital status. Okay. So this is it. I just want to do one way because I have just one dependent and one independent variable. So this is the result. Again, this is what we are going to look out for, because this one is for us to see if there's any difference between these groups and the mean age. Okay, so this result is telling us that there is difference. There is difference between the mean age across marital status. This is it. Is average age different across marital groups? And you know I have 7 groups there. So this result is telling me that truly there is difference between this average age among these marital groups. Now I hope I'm still here. My network is showing red. Please, can you hear me?
Yes, ma'am.
Okay, thank you. So this is ANOVA will just tell you. You will see one of my videos. That video is even trending when I say ANOVA can be unfair. So this result is just telling you that there is difference between the average age of these groups. This is it. Even between and within, it is significant. This is the chi-square ANOVA result. Now, there's something we call post hoc. If people want to know which one differs, is it the married one, this thing, that's when people talk about post hoc. But we are not talking about post hoc today. This is one way ANOVA. You test, is there difference? Yes and no. So that is it. The result is showing that there is difference between the average age across marital groups. That is one way ANOVA. We have the one we call ANCOVA. Let me just do it like a form of introduction. When you talk about ANCOVA will look at other factors that are likely to affect this result. Example is this. Let me use this one that will be so clear to us. This class that we are doing now, okay, good. Let's say this is online, right? Online. And I also put this, we have some online trainings that it is just anything you do online, that is the end. But in this training, you have option to go back like tomorrow, next tomorrow till Thursday to go and watch this video again, watch it, practice, then send question to the instructor personally. You can send question to me, you ask question, then sometimes I will bring you back on your own. I'll bring you back here to explain to you that this is what I was explaining, this, do you understand it now? Because there are some people that they can't learn very well, like when they are in group, they prefer one-on-one. But maybe because of money or so, like I don't have money for personalized class, but at least I can use this option that if I watch the video and I do not understand, I can still have access to the instructor and come back and ask question. The instructor can still bring me back to class to display and show me, or I will say, yeah, share your screen. It is in this cohort that I have smart people in all cohorts, but this one, like people are not really sharing their screen. In the previous one, you will see people will say, I want you to use my laptop to do it. So we are always rotating it. So this is good. Now this is one method of teaching. Now some people will train you online and they will say, okay, this is the training, we are doing it now, and the moment that class close, you don't have any video to fall back on. So it's either you write in class, and if you do not write, you do not practice, that's the end of that class. In cohort 1, the model I started the training with is that I want people to be present, because a lot of people will pay for training. Seriously, they will not attend. So I want you to be that come to class and they will say, I will watch the video later. Some people will not go back to watch that video. So I started like, I said, no, if you want to attend my training, you must be present in class. Forgetting that a lot of people, they will go to work, and because of time difference, some people will say, oh, I'm going to work, I pay, I was thinking that you will give me recording that I can fall back on. And that is why I developed this thing. Like any mistake I see in any cohort, I will build on it to make correction, and things keep getting better. Now let's say I have 3 methods. People that attend training online, they will get recording and you still have access to mentorship. people that will attend online training with no recording, then people that have online training, just online, you can either be present and write notes in class. Now we have three teaching methods, right? And we are looking at maybe like the score. If I give exam now and now look at people's income, I want to compare the average income of people that belong to group 1, group 2, group 3. Is there any difference? I want to look at it like that. That is what ANOVA will do. ANOVA will tell you that there is difference or there is no difference using the p-value. Case closed. But when you are talking about ANCOVA would still have these same three methods. You have their score. But ANCOVA will remind you that, do you know there are some people that even though they attend the training, they already have prior knowledge. Whether you give them video or you ask them to come for mentorship class, it may not really matter. So if somebody is having access to recording, the person still have access to mentorship, and this person already have prior knowledge. So it's not going to give you equal level for you to consider whether the method you use is effective or not. People already have prior knowledge. You will just be looking at it and say, even the people that would not even give anything, just be present in class, and they even have higher score than those that have access to training, mentorship and co. The reason is because they are not beginner in a way. Maybe somebody have been teaching them before, they have been saying it. Maybe they did not just practice. So as you are telling them, they are just grabbing it. So ANCOVA will help you to consider other factors that are likely to affect that result. Example is this one that I've stated. Because if somebody already have prior knowledge, how do you want to compare that kind of people with somebody that have not heard of it before, someone that is just new, a complete beginner? So please, do you have any question about this? ANCOVA is not part of the module, but at least we'll talk about it. You can also read about post-hoc. Post-hoc will tell you, if you run ANOVA, people will say, okay, let's do post-hoc because you want to know the group that is different from, that is having different results. So is it clear, SAS and maths? Where is Madam Oluwakemi? Church. Okay. So people of God, any question?
Hello, ma.
Yes, ma.
Can we run ANCOVA as well and just see how the results will look like?
It's not part of the course module, so I do not even have the data for it.
Okay.
I don't.
Okay.
But this is what I will do. I will try to make a video. I will now send to us. Do you get?
Fine.
I can even tag us on
Okay.
on this platform, TikTok.
All right.
Okay.
Thank you.
Okay. So thank you so much. Let me write it down because that's how I used to promise. I'm sorry. Please, if there's any question before we move to regression, please ask your question. Let me take it back so we can look at it and ask questions before we move to should I take it as no question? And cover video. I'll send it. So I should take it as no question, right? Or is anybody raising hand? Mr. Adeshino, any question? Mr. Ben, please ask question. Mr. Lawan, Mr. Omoshola, Madam Oluwatoyin already asked questions. So please, is there a question? Give me yes or no.
There is no question for now.
Okay, thank you. All right, thank you, Mr. Omoshola. Okay, so let's move to regression. I hope I have data for regression in this one with me. Okay, regression analysis. We have two types of regression. We have simple. Oh, it's more than well, we'll talk about simple and linear, and simple linear regression, then multiple linear regression. That is what we'll be looking at. We have other non parametric analysis that at the end of the day you can linearize it and still have regression. We'll talk about probe it if time permits us. If not, we organize another class, or I put it in video and sent to us. So we have regression. What does regression do? Regression look at relationship between one or more variable, more than one independent variable. So I'm going to recap that. Let me say it again. We have regression. Regression to look at relationship between one or two variables. So let me say that one. Now for linear regression, we have what we call dependent and independent variable. Dependent variable are the variable that you are trying to measure, or let me put it like the variable that changes as independent variable changes. So we call it dependent. It depends. An example is when you have y is a function of x. I'm sure we are familiar with this, right? I thought it can be bigger than this. Example is when you have y is a function of x. Y is the dependent variable, x is independent variable. So we call it simple linear regression when you have one dependent variable and one independent variable. It is called simple linear regression. It is linear because we are saying that the relationship between them is in straight line. For example, if this increase by 1, which is, if I say if it's times 2, where is my multiplication? If this is, it is not raised to power 2, oh, please let's pay attention. If I say x is multiplied by 2, I'm saying that the result I will get here will also be multiplied by 2. That is what makes it linear. But in a situation where I'm having raised to power this one, then it is no longer linear. The relationship is no longer linear. But in real life, how many relationship is even linear? That you can say is straightforward. So if I plant maize and I put two, let's say maybe like 2 bags of fertilizer, and the yield that I have, let's say I have 100 bags of maize, just example, 100 bags of maize. If I increase fertilizer to 4 bags, does that mean that we have 200 bags of yield of maize? I don't know if this example is clear. Is it clear?
Yes, yes, ma'am.
Okay.
That is not
So,
proportionate.
So that is it. So example of this simple linear regression is if we want to know that, like, okay, if we want to predict one numeric variable using another, that's when we are using linear. One numeric variable using another. Example is when you want to look at maybe like the quantity of food you buy in the market. We know it's a function of price, because if I have, let's say the money I have is, if I have 10,000 naira and I'm going to market and I want to buy, let's say egg. If I want to buy crate of egg, the money that I have will be the factor, or the price they are selling in the market will be the factor that will determine the quantity of this crate of egg I will take. Egg is now 5,500 thereabouts. So if I have just 10,000 naira, that means I will not be able to purchase more than 1 crate, and I will take my balance. But if I get to market and the price of egg reduced to like 2,000, that means I can buy 5. So it's a function of price in the market. There are other factors that can also determine, but when you are dealing with simple linear regression, one numeric variable, one dependent and the other one independent variable. So this is example of simple linear regression. Example is this: does years in a state predict the income? Another example is year of schooling, can it predict the income you earn? If somebody have primary school sat, for school sat, how many years of schooling is that? School sat, what's this one we call school sat? I believe it's SSC we call school sat. Ejo, please help me. Is it, am I correct?
Yes, ma'am.
If somebody should spend, that's like if you, let's say primary school you spend 6 years, secondary school you spend 6 years, that's 12 years of schooling. Does it predict the income you will earn? You can also look at, okay, now somebody that spent 12 years, let's say another person decided to move forward and say thank you. Another person move forward and maybe like do MSc. Let's say that person use like 2 years for MSc. That's already 14 years. And another one is using PhD. That PhD spend how many years? 4 plus another 3 years, because the minimum for PhD is 3 years. That's like 15 years, abi? 14 plus 3, 17, sorry. So I have 12 years, 14 years, 17. Mind you, it's not just going to be 3 people. We want to try to look at it like people that spend just 12 years, the one 14 years and 17 years. We want to know, does it predict the income you will earn in a company? You can have example like this. And that means the dependent variable is going to be income, the one you want to predict. Then the independent variable will not be years in school, years of schooling. So people will have 12, they will have 8, they will have this. Now, how do we do it? How are we going to run this analysis? If you don't remember, you can say help regression. We are down. Okay? Because regression is learning, right? Okay. So there are some situations where the team may not bring it. I already told us, put it online. It will give you the command, but this is it. It's under statistics. This thing we are doing is not graph, you know. Come to statistics, then come to linear. It's linear regression we want to do, then pick regression. Then which one is your dependent variable? I'm going to generate number. So I only have, let's say this age. Okay. I don't want to introduce bias. I'm looking for numbers, let's say, because it will not make sense if I'm predicting age. I may need to switch age and any other number I want to use. This is categorical. It will not make sense. This result is not giving me what I want. It's using the number beside it. So the best thing is for me to go and bring real number, because using this 23, 26, this is the year of schooling, and I'm using age as if it's, let's say it's income, but in thousand. So if somebody is 12 years, is 18 years, I'm saying 18,000. Okay. So you have this is how the result will come. The simple thing to write is, you will say, the command is regress. The first thing that you will put, the first variable that will be here is your dependent variable. The dependent variable, the y, it will be the first one here, which is, it must be continuous, please, for regression. For this simple or multiple, the first one must be continuous, because if I'm talking about probit regression, logit regression, you will see what I mean by that now. So this thing is regress. You will put the continuous variable you are looking at, then you will now, if it's let's say you have more than, you will start supplying. This one is ever attend school. This is age group. Then you start putting others if it's multiple, but this is simple linear regression. I want to regress age against let's say year of schooling. We drop that year of schooling and you will press enter. It will give you this your result. The first thing you should look out for is your p-value. You see how this one, this is just talking about the model. Is the model significant? It is not significant. This is it. This one is saying that the model is significant. Okay, maybe I should use this opportunity to explain R square for us, for an adjusted R square. This probability greater than F is looking at, is this regression, is this model, the model you have, regress age and this one dependent variable and the second independent variable, is it significant? The model is significant. This is it. But R square will now tell you that what is the proportion of the effect that this is having on the dependent variable. This is telling you that is 0.0144. I want to take it to percentage so that we understand. Please, if you are with calculator, you can also do it. I don't want to guess. This will be like 14%, 0.0144 times 100. Okay, this is 1.4. You see, that's how I'll go and call it 14%. So it's only saying that it explains 1.44% of what is happening to this our dependent variable. This is acceptable, but please pay attention to this. At least something should explain like 70%, even though the model is significant, because this is simple linear regression. So now you look at your p-value. Is this thing significant or not? I will switch data now, please. Is it significant or not? My people are far from their phone, or is it my network?
It's not clear. Me, I'm using phone, so I can't view what you are saying.
Why are you using phone, sir? What happened to your laptop?
I'm not at home.
Okay. It's okay, sir. Okay. So, Madam Oluwatoyin, Mr. Lawan, I will switch. I will go and get good data that will be able to make sense from. Okay. So this is p-value. The p-value is 0.000. It is significant. Actually, this is it. The p-value is this. So it is significant even at 1%. When you now look at this, oh, it is significant, good. You will now go to this coefficient. How many people remember this is equal to, we normally have b0. This is underscore, not b0. And you say plus b1. You will now have your x. Let me do it like this so that it will make sense. How many people remember this? How many people remember this, or you are seeing it for the first time? Is morale low? Should we stop here?
No.
No, let's continue now. Should be, at least you are talking about the relationship between the model,
Yes.
that's the intercept, the curve.
Yes. I should continue,
Let's give
right?
it a try, ma. Let's give it a try, yes, ma.
Okay, so if you remember this, you see this intercept, this one, intercept, is this constant that you are seeing. So most of the time, okay, just in case somebody is asking you and say, what does this mean? Let's do this example of when you say that the people, what will people will consume will depend on the income they earn, right? That's the normal theory. That is your income that will determine how much you will spend, right? But we have some people that they are not earning income, but they will still eat. So this one is constant, is a must. Whether you earn or you did not earn, something will feed you. Is either you borrow money or people will dash you food, you will still eat. This is like a kind of constant value. If you plant maize and you decide to say, oh, I don't have money for fertilizer, trust me, even on normal ground, if you see, you will see that there are some things that even if you do not plant seed, you will just notice that pepper is growing here, maybe by error or by mistake, or somebody pour the seed there, also it will still grow. This is like a constant value, constant K, like people will say, and this is the coefficient here. So this one, if I want to write it out, I want to, I can't do, except if I want to do enter. Please take it as if I'm in another page. It's going to be that age is equal to this constant 54.79. The value here is plus. This here, this constant I have is plus. I'll still write it as plus. Then this is the coefficient of x. This is the coefficient. This is it, the one in front of this education, highest education completed. But we are looking at it as if it's a year of schooling because of the number in front of it. So this time around, it is not plus, it is minus. Constant is plus, this one is minus. So the relationship is negative 0.015. Okay, so this is it of x. This x, which is highest edu or year of schooling, for the sake of those that will listen to the record. So this is the result you have here. So what is the interpretation? You have seen it, the first one, that is significant, perfect. You will use, this means that education level, year of schooling, for example, that we are using, and we are using this one as if it's income, significantly affects. So let's interpret it as if we have number. Year of schooling significantly affects age. It's not making sense because that value number is not really good. I will switch back. I will use it to test if you now understand what I'm saying. Significantly affect this. Now, what is the direction of the relationship? Is it positive or negative? This is telling you that it is negative. So this one is saying that the higher the number of years spent in school, the lower the income. For example, if this is income, that means it's reduced. This one is saying that the year of schooling reduce as age increase. That is what this is saying. So please pay attention. You will look at your model. If the model is significant, look at the R square. And what's the proportion that is explained by your dependent variable? Now, your p-value is the variable significantly related to your independent variable. After that, look at the direction. Is it negative or positive? Okay. So please, let's bring data that will make sense for this regression. And for the sake of those that still want to learn how to create view file, let's say this is what I've done. I just need to come here. I'll keep the record of what I've done and I will save it. But I'm not saving this. Okay. So for this regression, I want to do it again. I'm clearing the data that I have here. I want to use the inbuilt data. Okay. So I have new data. Please, let's not forget. I have this new data here. I just want to check. I want to know how the price will affect. Okay. This one will even be good for me to run probit. So I have new data here. I'm looking at a kind of example that I can set. So please pardon me. College week, research week, PQRS. I kept one data. Maybe PQRS. RS. I'm looking for research. Give me help me see, please. I did one note for them. We have not started quad 4 that time. See new. So we've started quad 4. Now wow. Okay. I use this to train staff. Okay. So for example, we can have regression like this. I want to look at income, education and age. It's not here. Okay. So does weight predict the price? I have car. Here I want to check if I want to do regression. And I want to see if weight will predict the price they are going to sell the car. This is automobile data here. This one that I have, don't forget I've already erased all of this one. I'm starting my work from this syntax auto. I can also clean my window so it will not affect us. So I want to do simple regression. I want to know if weight will determine the price the car will be sold in the market. The command is regress. Don't forget, the first thing that's supposed to come here supposed to be your dependent variable, then followed by independent variable. In this case, we are looking at simple regression analysis that we are doing. So here I have this results, regress price weight. This is dependent variable, then followed by independent variable. Now I will look at the model. If the model is significant, this is 0.000, it is significant. But here, what happened to price is only 29%, 29.01% of what happened to price is predicted by the weight of car. So that means other factor will actually determine how much a car will be sold, not just because of the weight. Okay, so now I want to interpret this result. The first thing is it significant? Yes, it is significant. Look at the p-value. So that means weight is significantly related to price. I will now look, the people now tell what is the effect. This is the sides of effect. So this is saying that 2.04, if the weight increase by just 1 unit, is in weight is in lbs, if it increase by 1 unit, the price of this of car will increase by 2.04. That's in naira, because this is not logarithm. If it's in log, we'll start talking about percentage. So it's saying that, let me come again, it is significant. We can see now what is now the meaning. It means that if the weight increase by 1 unit, depend on what your unit can be. For another person that is working with kg, one that is working with gram, so if it increase by 1 unit, the price of car will increase by 2.044. If this price, the unit is in dollar, it means it will increase by $2.044. If in naira, 2.044 naira. Is it clear? Are we here?
Yes, ma'am. Please, the one you just explained, now, can you just recap just from the price, between the relation between the price and the weight that you just explained, your last statements now?
Okay, thank you so much. There is significant relationship between weight and price of car, according to this data we are using now. Now we are now saying this is interpretation. We already know that there is significant relationship. When you look at it, you can see that this is plus. This coefficient is plus. That means as the weight of car increase, the price also increase. That is what it means when it is plus. As the weight of car increase, the price of car also increase. Now, but by what? What is the value? What is the effect of this impact? We are now saying that when the weight increase by 1 unit, this is 1 lbs, do you get? The price of car will increase by 2.04 naira or dollars in any unit that this price is measured. Is it clear, sir?
All right, ma'am. Yes, ma'am.
So price.
So, ma'am, the next question I want to ask, sorry, ma'am. The question I want to ask now is the coefficient. Is it related to, is it that slope or intercept from the formula? That's what I want to know exactly.
Okay. This is the intercept, and this is the talking about, this is the coefficient. This is it. When you have price, is a function of this, your b naught. This is the intercept, right? In this case now is plus, because the coefficient here is going to, if you write plus and the value you have here is minus, if it's minus 2.044, sorry, if it's like this, you will simplify it further. It will give you b naught minus, because plus multiplied by minus is minus 2.044. But in this case now it is plus, so please, this is it. I just use it as example so that people will not think it's supposed to be constant plus. So this is what this result is saying. Let me remove this so it will not confuse us. And the weight, this is constant. This constant is the value. We can suppress it. But this is constant, like it's giving you minus. You don't need it. A lot of people don't interpret it.
But why are you not including it in the model?
You can write it.
So it will be minus 6.70.
Okay.
Okay.
Are we good?
Yes, ma'am.
Okay. So if all these are constant, this constant, if this x, if this weight is not there, the price of this product will still be it will be minus. That's what it means. It will be minus. That means they are not selling it at any price. That's what intercepts measure now. Is it clear?
It is clear now, ma'am.
Okay. So interpretation of this result again is that the relationship is positive. You can see that means when the weight increase, price will also increase. When the weight increase, the price will increase. But by what unit? That is this coefficient, the B1 that you always see in econometrics or statistics class or in any analysis, in any model. This B0, this is it. It is called coefficient. It is one of the parameters that we measure in analysis. So when weight increase by 1 unit, the price will also increase by this. It will increase by 2.044. So if weight before is 7, the moment the weight of the car is increased to 8, and this price is just 10, let's say it's $10 before, it will now increase by 2.04, so it will become 12.044. That is the interpretation. I don't want us to think of it too much, but if it's not clear, please bring me back. Ask question, please. I can easily write clearly here. When you have y is a function of this coefficient that we normally write, we say plus the b1, then you put your independent variable in brackets, this. Okay, this is example of simple regression. That means I want to predict if weight can predict the price, and from our result the relationship is positive. If it's negative, this become minus, but it is positive. This is weight x, the coefficient is 2.044. so that means when the weight increase by 1, the price of car will increase by 2.04. I believe this one is clear, right? Can we move to multiple regression, please?
Okay, ma'am.
All right. So when you talk about multiple regression, it means you have one dependent variable and you have multiple independent variables. So it's more than one. It can be 2, it can be 3, it can be 4. And it's simple. The command is still regress. You put your dependent variable as first. Now we can consider the mileage. You can look at weight. All the factors that you know that will determine what happened to price, you put them in your model. So let's go through this, and I'll be watching if somebody will ask me a question, because there's something that is different here now. So I will do regress. I know that price, it will be when people want to sell their car, they look at mileage and say, the mileage is not that this thing now. You have the money is different from the. We want to look at it. Is mileage going to predict the price of car? Weight, is it going to affect the price? Then in this case now, I have categorical variable. It is domestic. Is it this one that I have here? Is it domestic or foreign use? Is in category. That's why I put I there. So when this is domestic and foreign. Domestic and foreign. Okay, if it is not well specified and you know there is category, so you should use this. We can also look gender, can also, like maybe the gender of the person that is selling the car can also affect. If you have the variable, you put it. Okay, so can I run this analysis? So case now, we have how many variables that we are using. So you will look at the model, it is significant. If you look at the R square now, it has increased. The R square is now 49.9%. So these variables that we put here now, they join together, they explain 49% of what happened to the price, which is better than when you just use simple regression. When you are looking at just one factor, what about the color of the car? Is it going to affect the price? What about if it's first body or second body? Is it going to affect? So that means you can still add more variable to your model. But let's take it for example. This is what you have. What is the interpretation of these results? So can somebody tell me, what will you look at for first? You have looked at the model and everything. Now you want to know this variable. Can somebody tell me the ones that are significant here? Anybody?
I think weight is significant,
Thank you, ma.
and foreign
Thank
the
you.
foreign too is significant.
So weight is significant and foreign is also significant. So we are going to be explaining these two. Let's start with weight. Can somebody interpret this result for me? Please interpret the result for us. How is weight related to price? So what is the relation between weight and price? Is it positive or negative? After you determine that, what is the effect? What is the magnitude? Regression will look at the direction of the relationship and the magnitude. So somebody should interpret this for us, please.
For weight,
Yes, ma'am.
weight is positive. The relationship is positive,
Okay, thank you.
while foreign is negative.
Okay. Is it negative?
Is it negative? Oh, it's positive. Sorry, I was looking at the
It's
constant.
constant that you are
It's,
looking at.
yeah, it's positive too.
So it's positive too. So this is interpretation of our results. Like what is now the meaning now? Madam, it's not hard. Oh yeah, let's do it together. I have this. This is the coefficient. Because the relationship is positive, it means that the higher the weight, the higher the price, right? So if weight increase by 1 unit, the price will increase by 3 points.
3.46.
Thank you. That is just
For
it.
weight.
That
Yeah.
is the simple interpretation. So it will increase by 3.46. This is where I think issue will be, which is okay. You see, foreign, it is categorical variable. I want to remember, like when you're analyzing, you must know which one is 1, which one is 0. Okay, this one is not telling me. That means I should use code book. Remember, I teach us about code book. I want to know which one is 1, which one is 0. Okay. Code. So code book for foreign, I want to know. So domestic is 0, foreign is 1. I will note it down. Domestic is 0 and foreign is 1. That means foreign car, if you are buying foreign car, the price of foreign car is 3,673 higher than the price of domestic. Domestic is 0, so you are moving from 0 to 1. We say the higher this variable now, permit me to say the higher the foreign, the higher the price. But you know that domestic is 0. We are moving from 0 to 1. So the price of foreign car is 3,673.06 higher than domestic car. Simple as that. Is it clear?
Yes, ma'am. Sorry, can I ask? So the R squared being 49.96 now, will it just relate to the significant independent variables?
No. This one is talking about model. The model we specify this one. You know, in this case now, we are now having y is a function of x1
Plus X2,
plus x2
three,
plus x3. How many variables do we have? 1, 2, 3. Just 3.
three. Yeah.
This is what we are stating. We now say plus, I don't know if you have come across error term. These error terms capture any other variable that is supposed to include this model that is not put. So we capture it under error terms. So you only have 3 variables here. So this is a model. This is a model. This is mathematical form of stating a model. We are creating a scenario. You know, model talks about like a kind of, it can be pictorial picture, and it can also be in mathematical form, mathematical model. This is a model. We are saying that the price of car, which is y, is a function of mileage, function of weight, function of where it is produced, is it local made or foreign made, and any other factor. We call it residual error terms. So another person can state the model and still put plus, let me see something we can, this displacement, gear ratio, or truck, let's use the space of the boot. I can still say x4, and I will say 5 and here. So now I have 4 independent variables. Some people can have 10, looking at the necessary factor that you can put in place to predict what will happen to your price. So this one is just talking about the model. You see, for R square, the higher the number of your independent variable, the higher this R square value. But you see adjusted R square, this one have a way of capturing it, not it will allow it not to be too in excess. Like it will still look at it, have a way, adjusted R square have a way of working on the R square in such a way that it is not just because the number is increasing that is saying that the model is better off. This one, this is the real thing we should look at, adjusted R square. It said that it explains 47.81% of what happened to price is determined by these 3 factors we have. So let's run this one. Let's what's the regression? Price, mileage, weight, foreign, whether it is produced locally. Let's look at the truck size. Maybe it will have effect. You see what I just mentioned? See how the R square just increased, but adjusted R square is the main thing. Like it's just 47.97. That's affecting that is telling us what affects the impact all these independent variables are making on dependent variable. So truck size actually is having negative, even though it is not significant, effect. So it is not about the truck. If the truck size, the higher the truck size, the lower the price. I like it like that. But it's not significant. But let's take for example that this, we want to interpret this. This is saying that the higher the truck, the size of the truck, the lower the price of that car. Men in the house, is that reasonable or not? Because I believe that it is not by size of the truck. Expensive cars sef, they don't really have big this thing like boots, for example. If you have all these sports, all these smallie car that people can easily say, oh, I can take it around, I can take it anywhere. So this is reasonable, but it is not significant. In academics, people explain what is significant. Any question? That's on multiple regression analysis. So this is it, interpretation of your results, whether it is multiple or it is simple linear. You look at the coefficient. It will tell you the direction and the size of that effect. And this is the beta. When the beta is greater than 0, as year increase, then the income also increase. But if it's less than, then that's when, you know, anything less than 0, that's already minus. If the independent variable increase, then there will be decrease in dependent variable. That's the simple explanation. So you will look at your coefficient and the p-value, then tell us the interpretation of your results. I say R square, we talked about the overall explanatory power of your model. It will say, oh, it explain only 40%, it explain 80%, 90%. But for professionals, higher levels, we know that the more you add independent variable to your model, the higher the number or the value of your R square. So we consider adjusted R square. Is it clear, please?
Yes, ma'am.
Are we sure? It is time. You can see that's why people are leaving. It's time so that maybe people have another engagement. So,
Is it actually-
sir,
I said it is actually clear. It is clear. It's
it
clear.
is clear, okay? So please, we have come to the end of this cohort session, but we are not leaving, because I promise that it's either I make video on what Madam Oluwatoyin asked us and cover. Then I also promise that I will introduce probit regression. I don't know if I should continue so that I will make it into this video, or I should make another one, because if you have another engagement, it will not be fair for me to not be taking your time. Should we stop here? I should make video and send to us, or I should give us the grace to go and watch this video. You know, it contains what we did yesterday and today. Let's go and watch the video, collect your question, put everything to me, push it to me on or before Thursday. Then I will come for lecture maybe on Saturday. But if we are okay, if I do not receive any question, then we are fine. Even if we receive question and you don't have time to attend, if there's any question from anybody, I will still call for the class on Saturday. We'll have the meeting, I will record it, then I will send it to everybody. Are we okay like that?
Yes, ma'am.
That's okay. But yesterday recording has not been sent. I
And
don't know whether I'm the
no,
only one.
I started all over today. I started
Okay.
from beginning
Okay.
today, so you will see the recording here. Are we good?
Yes.
All right, thank you so much. Mr. Lawan. Thank you, Mr. Adeshino. I can see your hand. Madam
Hello.
Oluwatoyin, any question?
No question, ma'am. Thank you.
So thank you so much. I'm going to call for another meeting. So we do final. Please come with question. I'm the one that's supposed to say, your time is up. But what is the benefit of attending a class if you have a lot of questions in your mind and we are not providing solution to it? It is even from question that when you ask something, I will remember, this thing, okay, let me talk about it. If it is not in the course module. So I don't know if anybody wants to say anything. Please, the floor is open. We are free to call my attention to one or two things. Please. Madam Oluwatoyin. Okay, so I believe we are good. I will stop recording now. Thank you so much, everyone.